All right, so here we are within Synera. This is the Synera editor, as we call it. This is where you build a multi-agent system. And what we would do first is we would bring in a team agent leader. So let's find that agent that we want. And that's pretty much the agent team leader. I have pre-built this node for me out of convenience because I use it quite often. And that team leader or supervisor, of course, has access to a large language model. In our case, this is Claude Anthropic. And this supervisor has, of course, also instructions. I'm not going to fill them out right now, so they're pre-filled. And what this team leader now needs is agents, right? So the first agent we're going to bring in is a sales agent. And the sales agent has nothing else to do than create nice images, because once we send out a quote to a prospect, we want to make sure that we actually have nice images. So what we miss here is, of course, the large language model. So every agent has to have access to the large language model. So now we just drag a wire down from here, plug it in, node is green, and we hide this wire. Done. So this supervisor now can communicate with the agent. And what is really clear is that the agent has also access to tool workflow. So if I open that drop down here, you can see a number of tool workflows that are actually running on our server right now. So I can assign only one tool workflow to that agent, or I can assign multiple workflows to that agent. So agent have access to any workflow you want them to have access to. So we need a few more agents. Of course, we need one FEA agent that we have to bring in, and we do the same as before. We'll connect the wires, assign an LLM. That's done. And we hide that a little bit. And we also want to bring in a cost agent, right? So here's the cost agent. We connect the wires again. And this time, maybe we want to use a different LLM. So we just type in large language model, use this node, and maybe use GPT 4.0. So the large language model you're using here can be online or offline. It really doesn't matter. We are agnostic to any. We have multi-agent systems. What else do we need? We need tool workflows. And what is a tool workflow? And the tool workflow is nothing else than a digitalized process that you have defined. So let's just build a tool workflow for this FEA agent. A simple FEA workflow that takes in a part and runs a modal analysis. And for that purpose, I've chosen a more simplistic part. So what the first thing that we need is an input relative file path. So now we'll just import this part, which is an NX file, and you see it's very simple. It's just a bearing mount, but that's good enough for now because this is agnostic. So whatever geometry comes into this workflow, it will run through this workflow. If it's a bearing or if it's a gearbox, it should run both. So first, what we want to do is we want to use these green surfaces and use them as a constraint for the modal analysis, right? In order to get these green surfaces, we have to filter the attributes. So we drag another wire, filter the attribute value, and the attribute value we want is the color green. Change the RGB value a little bit so we hit the right green tone. And voila, here we see these surfaces that we want for the constraints. So what else do we need? Maybe we need to clean up our file. So we see there's one solid body in our file, but a lot of curves, and we don't need these curves. So let's remove all these curves. We have a bunch of different remove nodes. That's a node we need. And now a solid clean body is coming out. Now we can use the solid mesh node from Hypermesh and just plug this in. So one thing is, of course, missing. It's the element size. And the easiest thing here is just to use a node that are created to measure the bounding box of the part and determine the element size. So very easy. Again, we get this node that we want. It's this node here, and job done. Oops, wrong wire. That's the right wire. And now this body will be meshed by the helper mesh node. Last but not least, we still need a node that runs the modal analysis. So we will run a solid mesh node that runs a solid mesh and constraint surface. So just select the solid mesh, plug it in, choose the geometry constraint surfaces, and run the simulation. Et voila. And we have our results. So our result is right here. It says that first node mode has 994 Hertz, and we ran the part in aluminum. Here we have one of those multi-agent systems live in action. So this is a multi-agent system that I named Digital CAE Coworker. The objective of this multi-agent system is clear. It has to process CAD data. It has to simulate a part, so run an eigenfrequency analysis. And it also has to create images. So what we're going to do here is pretty much we have to provide the supervisor or this agent with geometry and then give an instruction. So what we can do now is we can just ask it, can you run a modal analysis of my part? And of course, we have to provide a part. Let me just find that one. The one that we want is this one. Now we let the node upload and we prompt it. So now you see the supervisor starts working. And he's trying to process our language input. And the next step, he's already calling the 3-shaft gearbox eigenfrequency agent, who's pretty much taking up the task to simulate this part. And now he's going to run the simulation live on the server. So he's opening a software tool like an X, he's importing that, modifying a few parameters, and then he's processing data. He's going to mesh the part and run a Nastran solver in the background. So our multi-agent system already finished. It ran the same workflow that I have built, but of course with different results. First mode with 369 Hertz and with a different geometry. So this is really the power of agents.